Okay, so now we're going to look at this question 8 from the specimen paper that's in your past paper packs. So part A is similar to the last question we did, and part B is just a little bit different. Let's have a look at it. So part A is asking us first of all to find the Maclaurin expansion for e to the 3x. So f of x equals e to the 3x. And the first thing we're going to do is differentiate e to the 3x. Chain rule, 3e to the 3x. And we're going to find the second derivative. Chain rule again, 9e to the 3x. Third derivative, chain rule again, 27e to the 3x. Okay, and obviously to enable us to substitute into the Maclaurin expansion formula that you get on your formula sheet, we need to find f of 0. So that would be e to the 0, which is 1. We need to find f dash 0. That would be 1 times 3, 3, and so on. Second derivative, subbing in 0 gives us 9. Third derivative, subbing in 0 gives us 27. So that means that the Maclaurin expansion for e to the 3x is 1 plus 3x plus 9x squared over 2 plus 27x cubed over 3 factorial, which is 6, plus ... Simplifies to 1 plus 3x plus 9x squared over 2, and our 27 over 6 simplifies to 9 over 2 plus ... And that's the expansion for e to the 3x up to and including the x cubed term. So now we need to move on and look at the second part of this question, which is doing the same thing, but this time g of x is x plus 2 to the minus 2. So starting off the same way, we need to find g dash x, or first derivative, and chain rule, minus 2 x plus 2 to the minus 3 multiplied by the differential of the brackets, which is just 1, so we don't need to worry about that. Second derivative, chain rule again, 6x plus 2 to the minus 4, and again the brackets would differentiate to 1, so we don't need to worry about that. And the third derivative, minus 24 x plus 2 to the negative 5. Now we're going to substitute 0 into all of these, so if we rewrite them with positive powers, it makes the substitution much easier. So just rewriting everything with a positive power gives us that. So g of 0, well, the bottom line is going to be 0 plus 2, 2 squared 4, so that's going to be a quarter. 0 plus 2 is 2, 2 cubed is 8, so that would be minus 2/8, which simplifies to minus a quarter. Bottom line, 0 plus 2 to the power of 4 is 16, so 6 over 16, simplifying to 3/8. And the third derivative, 0 plus 2 to the power of 5 is 32, so minus 24 over 32, which simplifies to minus 3/4. So all we need to do now is substitute that into the Maclaurin expansion from your formula sheet. So it's g of 0, which is a quarter. Then we've got g dash 0 minus a quarter x, then the second derivative 3/8, and that's x squared over 2, and then the third x cubed over 6, and so on. So we just need to simplify it. Minus a quarter minus a quarter x, that's going to be 3/16 x squared, and we're going to have 3/24 there, which would simplify to minus 1/8 x cubed plus dot dot dot. So that's the expansion for x plus 2 to the negative 2. So looking at the B part of the question now. So the B part of the question is asking us to work out an approximate value of h of a half when h of x is x e to the 3x over x plus 2 all squared. Now what we need to realise is it's obviously connected to part A. E to the 3x, we've got an expansion for e to the 3x, and that's really your f of x. Now this is the same as 1 over x plus 2 all squared, or this is the same as times x plus 2 to the minus 2. So it's actually x times f of x times g of x. And that's what h of x is made up of. So all we need to do is substitute a half into f, a half into g, get what those are, and then substitute in a half for x, and then work out that whole thing. So first thing we're going to do is work out what f of a half would be. So it would be 1 plus 3 times a half. I'm just substituting into the expansion. So 9 times a half squared over 2 plus 9 times a half cubed over 2 plus blah blah blah. And if you work out that in your calculator, it is 4.1875. We then do the same for g. So sub in a half, and a quarter minus a quarter times a half plus 3/16 times a half squared minus an 1/8 times a half cubed, and that gives us 0.15625. So h of x, or h of a half, is going to be a half times f of a half, which is 4.1875, times g of a half, which is 0.15625, and working that out in your calculator, you end up with an approximate value for h of a half to be 0.327.